welcome back to another MyTutor online school tutorial. Today we're doing GCSE Maths, Congruence, Similarity, and some common trig ratios. So a lot of stuff to get through that will hopefully be interesting. So this session is 1 hour long, so we'll finish at 12 p.m. at midday. So this is me, Molly. I feel like most of you know me by now. It's mostly the same people coming back. But I am just finishing my second year studying computer science and maths at the University of Bath. And I've done over 200 lessons with my tutor. So hopefully I know what I'm doing, as I say every time, and then prove that I don't. So whilst we're doing this session, please do make really great use of the chat and Q&A functions. Just kind of pop your answers on so that I can see that everybody's on it. Ask me any questions, like ask me to go back to an example, do another example, tell me to slow down or speed up. If I get excited about maths, which I frequently do, I tend to speak quickly. So do tell me if I am speaking too fast. Okie doke. So today the format will be exactly as we did yesterday. So we're going to start off with like a beginning Kahoot, just kind of chuck you in the deep end, see what you already know, and I'll write down your percentage, like the overall percentage that everybody gets of all of the questions. And then whilst I'm talking, I may as well get the Kahoot ready. So here we go. To see the percentage that we get. Then we'll do the lesson, which will be kind of in the format of we'll do some congruence, some similarity, some trig ratios, and I'll ask you questions throughout, make it quite interactive. Then we'll do exactly the same Kahoot at the end, and fingers crossed, the percentage that people get correct increases. And as I said last time, if it decreases, I might just curl up into a ball. But here you go. So here's the Kahoot game pin. What I'll do is I'll put it on the chat as well in case I've started and people have missed it. So let me pop it here to go. Wow. Okay, so there are 28 of you here, so I'll wait until there are 28 or that people kind of stop joining. Oh, you're boring is a quote from Brooklyn. Of course it is. You're boring. Oh, it is. Love Brooklyn Nine-Nine. Okay, I'm no longer offended by that nickname. Thanks, everyone. Okay, is anybody still waiting to join? Okay, someone's still waiting. Oh gosh, someone said, "What's my favorite name in the lobby?" Well, now I like You're Boring because I like Brooklyn Nine-Nine. Big fan of 10 PRs to bag. That's a solid one, and obviously Maths Made Easy, my favorite website. So some strong ones. Someone said to do this, solve sign 30. No, because then that'll give it away for if it's a question. Not being tricked. Okay, is anybody still waiting? Oh, there are more of you now, so. Anybody still waiting? I'll put the pin on again in case anybody missed it before, because I think when you join it, you don't see the chat from before. Okay, I'll get going and you can just like join. I think you can join as it's going. So there's the game pin and we'll start. Okay, so this first one, which of these two triangles are congruent? Don't worry if you have no idea what this means, you can just leave the question. And And by the end, hopefully, we'll be able to tell which one of these are congruent and give a reason. Okay, so a lot of people got it. A lot of people were fooled by A and C. Yeah, I can totally see why, but we'll see at the end why the answer was A and D. So well done to the people that did get that. Okay, so a similar question, which two of these triangles are congruent? Again, if you have no idea what congruent means or you don't know how to answer the question, this is definitely going to be a good hour for you. Okay, wow. I guess that means that there's a lot to go through here. So a lot of people fooled by this one. That makes sense. I can totally see why. That's kind of a good thing. It means we have a lot to learn to go through. Okay. So here, what is the length of X? So now we're moving on to similar shapes. That's what this is. So again, if you don't know what similar shapes are, or you have no idea what this question means or how to do that, don't worry at all. The point of this is to, like, I don't expect this to score very highly at all. So that's okay. Well done. Lots of people got that. Yeah, yeah. So you can also think about this in terms of enlargement as well. It's a similar concept. So well done. You got that. So here, a similar one. What's the length of DC? Bit trickier. Oh yeah, well done. Loads of you got that. Fantastic. Okay, it looks like similarity is a good one. And this is useful as well because it means that I'll spend a bit longer on congruence because everyone's doing really well on that. What? See, this is why I didn't answer it. You've got to answer it. What's sine 30? No calculators. I mean, I can't stop you, but please try not to use your calculators because that's the point of this. This could come up on a non-calculator exam. So I'd much rather you didn't. Yeah, 0.5. Sine 30 is a half. That's everybody's favorite trig ratio. And by everybody, I mean probably nobody. Nobody probably has favorite trig ratios, but it's a very common one that comes up. Okay, so how about this? What's cos 30? And do not use your calculators. Okay, still the majority got that, but there are some that didn't, so that's fine. It's root 3/2, and I'm going to show you ways to remember these and work them out and stuff. So, okay, and finally, final question: what is tan 45? So when we look at our common trig ratios, we'll be learning all of these, and as I said, hopefully ways to remember them. Yeah, brilliant. Lots of you knew that, so well done. Okay, so First of all, let's have a look at the podium. So let's see who knew their stuff even beforehand. Yes, my name in a heart. The real Molly, amazing. Loving the nicknames. And in first place, dun, 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 Louise. So well done, you three. All got 6 out of 7. So let's have a look on the report and see. I'll grab some scrap paper and write down what the percentage was. So 40% correct. So that's still pretty decent. In university, that's a pass. So, you know, before the lesson, you're passing. So that's pretty good. Okay, so we'll play it again at the end, or like near the end of the lesson, and hopefully it becomes more than 40%. So that's what we'll do. Okay. So let's get started. So we're going to start off by talking about, let's start off with congruence, because it's the one that was the hardest for people, so it will take a little bit longer. So congruence, spelled like this, means identical. So two congruent shapes are identical shapes. So they have exactly the same side lengths and exactly the same angles. So for example, all that's different is the orientation. That's in fact, that's not even an example. That's just what it is. All that's different is the orientation and the placement. Now, congruence, we're not always going to be given all of the sides and all of the angles. So there are 4 ways that we're going to be able to tell. And I'm getting this from my favorite. Don't worry, guys, we're back. It's Maths Made Easy. There's a. I'm not cheating on Maths Made Easy today. It's the only website I've got. So don't panic. So there are these 4 things that we kind of have, and if we can prove any of these, then we can prove that 2 shapes are congruent. And that's kind of what a lot of the questions are, is like, prove that these 2 shapes are congruent, which I think is quite scary, because it's like, how do I prove it? But we can do that using these. So I'll explain what each of these are. So the first one is SAS, or side angle side. And what this means is that if we have 2 side lengths and the angle between them. So if we have 2 triangles like this, and we know that this is 6 centimeters, this is 8 centimeters, and this is 40 degrees. And then over here, we have this, and we know that this is 40 degrees. This is, oh gosh, let me get this correct, 6 centimeters, and this is 8 centimeters. We can see that we've got these 2 sides and the angle between them. So what we would say is that by side angle side, by SAS, these triangles are congruent. So, oh, someone's just said that in the question that people got wrong, it said which 2 triangles, not 3, are congruent. Maybe it did. Yikes. Oh well, maybe I lied to you. Okay. So if we have this, then they're congruent. By the way, the reason that we need these is because if we just have something like, if we have this where we have an angle and say 2 other sides, but not ones that are either side of this angle. So say this one and this one. I'm just making sure that I get this right. Make sure that they're definitely not, yeah. And this one. We cannot prove that these are congruent. Even though they look like they are at the moment, these side lengths could actually be different. Like, these don't have to be the same triangle there. So in order to prove that they're congruent, we're going to have to use one of these 4 rules. There's not really any real way to remember them. Someone's asked kind of, how do you remember what they are? I guess SAS and ASA are the same but kind of inverse. So you either have 2 sides and the angle between them, or two angles and the side between them. And then there's side, 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 so all 3 sides, and then this special right angle case. So I'll show you what they all are. So this first one here that we did, this was SAS. So now let's have a look at angles, side angles. So as I promised, this is two angles and the side between them. So kind of the opposite of this one. So if I draw two like this, it looks the same again. If we have this angle and this side between them. So here, again, you've kind of just got to visualize the orientation and make sure that it's the same ones that you're talking about. These we're allowed to say are congruent by ASA. We've got two angles and the side length between those angles. And if, as long as they're the same, then the triangles are congruent. Someone said, is this higher? Good question. Let's have a look at what grades it says on here. No, it's just, I think this is foundation stuff. Similarity can get into higher a little bit, and trig values can, like the common ones to memorize, are probably in higher. But this is probably foundation stuff. That will also be in higher. Okay, so the third one, side angle side, just trying to make sure that you can kind of see it all on there. Okay, side, side, side. So this is exactly what it sounds like. If we've got all of the sides, 6 and say 4, and another one that has the same, as long as they're kind of the same way round. So here we've got 6, then 4, then 5. As long as this is 6, then 4, then 5, or as I'll show here, 6, then 4, then 5. You know, they've got to kind of be going the same way round. Then these are congruent triangles. And then finally, this one, RHS. This one you've just got to remember is the special kind of right angle triangle case. Someone said, is there a quiz today? Yes, we did do one at the beginning. I don't know if the person who's asking that has come later, and we're going to do the same one at the end to check the difference. So then finally, this RHS, this is the right angle and the hypotenuse, and then the other side. So if we've got a right angle triangle and we have the length of the hypotenuse and either of the other sides, and we'll draw the same one here. Gosh. This one. Then these two are congruent as well. So even though it doesn't fall into the angle side angle, because the angle isn't between, sorry, side angle side, because the angle isn't between, because it's a right angled one, we know that these are congruent. So these are the only 4 ways that you can prove that something is congruent. So hopefully that makes sense. Cool. So I think the best way to do this is just to have a look straight away at some questions. So let's have a look at this worksheet. Okay. So some of these don't even have any side lengths at all, and you have to kind of prove it by this method. So here we have AB equals BC equals CD equals DA. So that's what these lines mean, that all of these lines here are of the same length. And we want to prove that triangle ADB is congruent to triangle CDB. So which one do you think we'll use here? Which of these? So is it SAS, ASA, SSS, or RHS? Which one do you think it is here? Pop it on the chat. Brilliant. 3 people have already got it. Someone said, is maths made easy for all exam schemes? Yes, this sheet is actually from an edXL sheet, but it's still applicable to all of them. Like these could be applicable to any exam. Brilliant, loads of people have got this. So this one will be side, side, side. So the reason that we say this, and you have to be quite kind of thorough when you say everything. So we have to say, so here this is okay. So we can say that BC equals, and we're going to kind of say that this is this triangle, but like rotated round. So we're going to say BC equals AD. And we can just say as stated, because that one is just given to us. And similarly, DC equals AB as stated. And then, so we've proved this and this, so we just have to prove this. Well, that's the same. So then we just say BD is a common side, or a shared side, one of those two words. And then we say therefore, so these 3 dots in a triangle, bit of maths notation for you, this means therefore. Basically, mathematicians say therefore a lot, and we can't be bothered to write out that whole word, so we just draw some dots. So if you see me writing this, this means therefore. And if you write this in an exam, your teachers will know what you mean as well. This is a universal notation. So therefore, ADB is congruent to, oh, I wonder if there's some quick notation for is congruent to. Is congruent to notation. Oh, okay, we can use the same, okay, there you go. So apparently if we write this, basically this is just me being even more lazy, just proving that I'm a mathematician. If we write this, that means it's congruent to, apparently. So ADB is congruent to CDB by side, side, side. And again, if you just write this by SSS, your teachers, your examiners will know what you mean, because these are universally accepted proofs of congruence. So hopefully that makes sense. So you can see how this is an easy one to see, but the thing that's harder is kind of writing it out formally. You know, it can be a bit tricky to see how you're actually supposed to write it out, and that can get a bit confusing. Is there a symbol for by? No, because that's only 2 letters. Mathematicians are okay with this. Okay, so we'll have a go at another one. So here. So here we're told, right, so ABC is an equilateral triangle. D is on this line such that this is perpendicular. So we want to prove that triangle ADC is congruent to triangle ADB. So how do you think we can, like, which one will we use for this? Cool, a lot of people have got it right. So the one that we're going to use for this is RHS. Brilliant, and people have already started to kind of prove it as well. So the one that we're going to use is RHS. The way that we can tell this is normally, if there's a right angle involved, that's going to be the easiest. If there's a right angle and we know the hypotenuse the same, then it's probably going to be that one. So here's what we say. We say that, so remember, you have to go through each step, each angle one by one, and say what it is. So we're going to say that, oh, and this is the other thing. We can say angle ADC to mean this angle here, or we can write triangle ADC to mean the triangle where you connect it back up. So this is just some other notation that I will be using and that your examiners will know what you mean. So angle ADC equals angle ADB, which equal 90 degrees. And you just put in brackets given. All that means is that I'm not just making it up, it's given to me in the question that this is perpendicular. So we've got our right angle. So now we need to remember it's RHS. So we need H. So then we say AC equals AB as ABC is equilateral. So remember, in an equilateral triangle, all of the angles and the sides are the same. So now we've got our, if we just write this down for ourselves, we've got our R, we've got our H. So now we just need one of the other sides. Well, if we look here, AD is shared. So of course it's the same because it's the same thing. So we can just say AD is a shared side. And there's our S, there's our other side. So then we just say, therefore, triangle ADC is congruent to triangle ADB by RHS. And I feel like if you write that, look how fancy you look. You've used therefore, you've used a congruent symbol, you've used some fancy. So hopefully that makes sense. Let me just check the Q&A and something. Okay, cool. Okay, doke. Now let's have a look at another one. What was part B? Oh yeah, okay, this is quite interesting actually, as a part of that. So also, did you see on here, this is 3 marks. And most of those marks come from just writing this out neatly. So it's all stuff that we know, that we can see, but you've just got to write it out. Okay, so this says, hence, prove that BD equals half AB. So basically that this bit is half of AB, really? Oh, okay, yes, that makes sense. So does anybody have any ideas about how we can do this one? Prove that there? Someone said, in the sentence BD is common to both triangles. What does that mean? I think you mean AD. Basically, it means that when we draw this triangle, so I'll draw them in different colors. When we draw this triangle and this triangle, that line AD there, they share that line. So that line is the same in both triangles. And that means that that side is, of course, equal in both of them. So it's kind of like saying AD equals AD, if that makes sense. Okay, yeah, this one, I think people are struggling with this. It's quite difficult. Someone said equilateral triangles, which is perfect. CD. BD equals CD, yep, and BC equals AB. So yeah, that's pretty close. So, okay, so here's how we're going to do it. So because these are congruent triangles, that now we've proved that they're congruent, we know that all of the angles and the sides are the same. And if the side's the same, again, if I draw out these triangles again on here, we've proved that they're congruent. So now we can say that these two bits here are equal. So BD equals DC by congruence. Whoop. By congruence. And if they're the same, then that means that BD is half of BC, right? Because these are equal and 2 of them make up this whole thing. BD must be half of BC. So we say, therefore, BD equals half of BC. You don't need to explain that one. That one is kind of obvious. If 2 of them are the same, then it's half of this whole thing. And because BC is equal to AB, because it's equilateral, all of these sides are the same. So we can just say that equals half AB. And then because it's a proof, we can either, this is more fun mathematical notation. You can normally at the end of a proof, you draw like a little box like this. This is some university level stuff, but I think I was always like, I wish I'd learned that in school. So when you finish off a proof, we can even do it here actually as well. At the end of this proof, draw a little box. That just means proof is finished. I've proved it. Yeah, and I hated that they only taught me that at university because it makes you look so cool and make you feel smarter. So hopefully this makes sense here. The notation might be a bit confusing, but all you've got to think is that because we can prove that these two are equal because we've just proved that they're congruent. Therefore, this whole side BC is double what this is. So is this, because they're all the same because it's equilateral. So No one said anything in the chat, so I'm assuming that that all makes sense. So let's see if there's another. Oh, wow, this looks like a tricky one. This looks like one that initially looks tricky. Let's see. It's only a 3-mark question though, so I think it will be like an okay one. Sorry, just checking everything. Okay. Okay, so normally all of this stuff is kind of telling you stuff that looks obvious from the diagram. So this diagram shows triangle ABC. Now this is important. LMNB is a parallelogram. So we know what that means, right? We know that this means that BN is equal to LM, and BL is equal to NM. We know that because it's a parallelogram, so that's important. Where M is the midpoint of AB. Sorry, L is the midpoint of AB. So this is halfway down this line. That's important as well. M is the midpoint of AC, so it's halfway down this line, and N is the midpoint of BC. So we've learned some really interesting stuff actually from reading that there. Okay, someone's saying they can't see the screen. I think other people can, so please don't spam the chat. And then we want to prove that triangle ALM, so this one at the top, and MNC, so this one here, are congruent. And again, here it says you must give reasons for each stage of your proof. So I'm just having a look myself to see how I would do this one. Okay. So does anybody have any ideas about what the which rule we'll use here, or where we can start, or what we can see? Okay, interesting. Different ideas going on. Yeah, okay. Yeah, there's some really good things happening. Cool. So what we're going to end up using here is SSS, which I think Louise said, so that's really, really good. So well done. So I'm just going to get rid of this. So this one's a bit trickier to spot, but it's okay. So the first thing that we're going to say is that AM equals MC, as M is the midpoint. And a few of you spotted that, so that's really good. See, if M is the midpoint here, the definition of the midpoint is that AM is equal to MC. So we've got one side. We've got one side. So now let's look for the other sides. Now we can see that BN and LM are the same because this is a parallelogram. So this helps sometimes if we write this out like this. So BN and LM are the same. And we also know that BN and NC are the same because N is the midpoint. So for the same reason here about M, we know about N. This is the midpoint. And what we can see from doing that is that LM is equal to NC. And remember, these are the triangles that we're looking at. So that's our second side. Hopefully that makes sense. So the way that we're going to formally write that out is by saying BN equals LM by the fact that it's a parallelogram. That is poor handwriting, I'm sorry. And then say BN equals NC as N is the midpoint. Therefore, LM equals NC. Because you see, and this is all this is writing out exactly what we said here. This is the same as this. This is the same as this. Therefore, those two are the same. And we're just writing it out in some fancy notation. So hopefully that makes sense. So yeah, and that's our next side, these two. Now, I think someone's already got it in the chat, which is really, really good. The next one is exactly the same by the parallelogram. So let's do these in a different color. So we know that this line is equal to this line because it's a parallelogram. And we also know that BL and LA are the same because L is the midpoint. And therefore, we can see that NM and LA are the same. So let's just, I'm just going to split this up so that you can see what the sections are. So then we say, it's exactly the same thing. So NM equals BL by the fact that it's a parallelogram. And then BL equals LA as L is the midpoint. Therefore, NM equals LA. Someone said, what grade is this? One like this. I mean, Maths Made Easy calls it a grade 3, but this is definitely more than a grade 3. So I would call this maybe a grade 5. So then we see we've got a side here, our sides here, these red ones, and the side here, the blue ones. So then, final step, all we have to say is therefore, triangle ALM is congruent to triangle MNC by side, side, side. Proof is complete. So you see all of that, you can kind of see fairly easily eventually. But yeah, it's this writing out. But honestly, the writing out is just, as you can see, it's really methodical. So that's all we have time for on congruence. So hopefully that makes sense. Just remember SAS and ASA, SSS and RHS. And hopefully you'll be all right. And remember that nothing else works for it. Someone's put, if we put the little box and the proof is complete, will we get marks? The little box won't get you any marks at all, but it helps the examiner a lot to see that you've finished your proof. I think it's a really good thing to do because it also, I don't know, it just makes it a nice kind of format, go like, therefore, this is the solution that we want, finish the proof. And also it means that the examiner will be on your side and think that you're a great mathematician. So you always want the examiner to be on your side. Okay, let's move on to have a look at similar shapes, which you all did super, super well before. So let's go to here. Where's this? This one here. Okay. So let's have a look here. Now, similar shapes are like congruent shapes, so they're kind of the same scale, but they're not the same size. It's basically enlarging a shape. All of the sides kind of stay in the same ratios. So let's have a look at this one here. So we have that AB and XY are parallel, and XP is 12.5, AB is 6, XY is 15, and we want to work out the length of BP. So this one here is our X. So the way that we do this is we say, someone said, isn't similar shapes to do with scale factors? Yes, exactly right. So similar shapes are all about scale factors, which you all got really, really well last time. So go away, McAfee. So does anybody have any ideas about either what the answer would be or how we can do this? Brilliant. Louise has got it. Yep. So Z saying 15. over 6, that's perfect. Manav's got it as well. Perfect. So what we do here, I'm just wondering actually if it says on here about how you prove that shapes are similar. No, I think they should just tell you that they're similar, because I don't think you can do a proof like I've never had to do that anyway. So yeah, they should tell you that these here are similar shapes. And what that means is that the ratio of all of the sides is the same. So let's work out what the scale factor is. Obviously, this triangle on the right is bigger. So if we do 15 divided by 6, we get 2.5. And what that tells us is that this triangle is 2.5 times bigger. So then to work out what x is, we see, well, what's 2.5 times smaller than that? It's 12.5 divided by 2.5, which gives you 5 centimeters. And loads of you got that, or at least made the start with 15 divided by 6, which is perfect. Someone also said that you could do 6 divided by 15 and times that by 12.5. Yeah, that's exactly the same thing. That's perfect. Okay, so hopefully that makes sense. We'll have a look at, another. Let's have a go at this one. So we've got this here, and triangles ABE. So this one here and ACD are similar. So remember, all that means is that the big one is just an enlarged version of the smaller one. So our question here is going to be to calculate what BE is. So what do people think this one is, or does anybody have any ideas about maybe how to start it? Calculate the scale factor, exactly right. Okay, cool. So let's give it a go. So the tricky thing here is that you've got to remember that this big triangle that we're looking at is this whole thing. So this length is actually 12 centimeters. And I think that's a tricky thing to remember sometimes. So what we're really dealing with, I often draw them out as two separate triangles. So we've got our big one here, our 12, 7, and we don't know what this is. And then our smaller one here, which has 9, 6, and we don't know what the bottom one is. The only way that we can tell what the scale factor is by seeing the sides that we do have two of the same of. So here and here. So we have a look for that. So the scale factor here, let's do 12 divided by 9. Well, that's the same. Say this is on a non-calculator, so we want to give that a go. We do reduce this, divide the top and the bottom by 3, and we get 4 over 3. So that's what the scale factor is. This is 4 over 3 times bigger than this one. So we need to do 7 divided by 4 over 3. And it can help sometimes if you write this down. As soon as you know that to get from here to here, we're multiplying by our scale factor. And to get from here to here, we're dividing by our scale factor. Sometimes noting that down for yourself can really help tell you what's what. So to get from here to here, we're dividing by our scale factor. So we do 7 divided by 4 over 3, which we know is the same as 7 times 3 over 4, which is 21 over 4. Or if we want it as a decimal, 5.25. So that's what that length is there. Hopefully that makes sense. Yeah, brilliant. A couple of people got that, which is really good. And so what will this length here be? What will, in fact, yeah, let's do this way. What will ED be? So just this little bit here. How can we work that out? Okay, so the way that we're going to do this is first of all work out what AD is on here. So we know that we times it by 4/3. So AD equals 6 times 4/3, which is going to be 24/3 or 8. So then we see that just our ED part here is 8 minus 6, which is 2 centimeters, which I think a couple of you got right. Yeah. Well done. So that's all we're going to go over on similarity, because I've just got to get the trig ratios done, and then we'll move on to doing the Kahoot again. Cool. So, but everybody did really, really well on the Kahoot with similarity at the beginning. So I just wanted to do it briefly. So hopefully that makes sense. Okay. So now let's go over our trig ratios. So these are ones that come up on a non-calculator paper, so a paper 1, where you just have to know them. And this is the table that you need to know, basically. Yeah, and it looks horrible to start with, but we can definitely, I think there are some really nice ways that we can think about this. So the first way is just to memorize it. Now, just memorizing it is what I did for my GCSEs and A-levels, and I'd encourage you to kind of come up with a similar way that works for you. Here's how I thought about it. So I always wrote out the table like this, going from 0 up to 90. Now for sine, here's what it is, going all the way across, and I'll prove to you why in a moment. So it's root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. So for sine, going from 0 up to 90, so 0, 30, 45, 60, 90, this is what it is. And can you see here that root 0 over 2 is just 0, root 1 over 2 is just 1 over 2, root 2 over 2 can also be written as 1 over root 2. This one you'll see in both of these forms. These are the same number. This is just if you rationalize the denominator as this, it doesn't matter which you use. Root 3 over 2 we just leave as root 3 over 2. And root 4 is 2. So root 4 over 2 is just 1. So hopefully you can see how this is this thing. So hopefully you can just kind of remember that. And then cos just goes backwards. It goes from root 4 over 2 all the way down to root 0 over 2. So instead of 0, it's 1. These two are swapped. This one's the same. And this, so you just go backwards. So sine and cos are actually super easy to remember. It's just root 0 over 2 all the way up to root 4 over 2, which I think is pretty easy to remember, as long as you remember these key ones here. So it's just 0, 30, and then it goes up in 15s, and then it's 90. Hopefully that makes sense. Let me know if that's helpful. And then for tan, these ones are a bit trickier. This you kind of do just have to remember. So this is, I always remember tan 0 is 0 and 45 is 1. Those are just ones that I kind of remember. And that 90 is undefined. And you can remember this from what our tan looks like. Remember, it looks like this. So we see here at 0 it's 0, 45 is 1, which you all remembered anyway, and 90 is this asymptote, so it's undefined. And then I just remember that it's 1 over root 3 and root 3, and that the smaller one, 1 over root 3, is for the smaller angle. That's just how I remember that. Someone said, why is it undefined at 90? That's because if you look at the graph, this is an asymptote here, which means that it tends towards 90 there and there. So if you put in tan of 89.99999, you'll get a huge positive number. And if you put in tan of 90.00001, you'll get a huge negative number. But actually tan of 90 doesn't exist. It just tends towards it. It's kind of like the same thing as how you can't divide by 0. If you divide by 0.000001, you get a huge number. If you divide by minus 0.9999999, you get a really, really tiny number, but you can't actually divide by that 0 there. Okay, so does anybody have Any questions about this? Someone said, can we do the quiz now? Yeah, just 1 minute. I just want to show you one more thing. So the other thing is the way that you can derive these. So if you're really, really stuck and you've forgotten, here's what you need to do. So let's say we're looking for the ones, let's say we're looking for our 60 degrees. We've forgotten our 60 degrees. Okay, so what we do is we're going to draw, we always draw a right angle triangle. And we're going to draw it so that it has a 60-degree angle. So we'll call this one 60, and that means that this other one is 30 degrees. And then what we do, let me make sure that I get this right. So to start with, let's call these two sides 1. And now we have, and so say we're looking for tan 60, we're going to call these 1 because we're looking for the opposite and the adjacent to 60. So if we remember our SOHCAHTOA, don't worry if you don't exactly follow this, this is just a bonus bit of how we derive them. So TOA, tan, so we say that tan 60 equals, is this what I mean? Maybe not. Tan 60 equals, because then it would be 1. Maybe I should have done a different one. Derivation. Yeah, so here, there you go. You call it 1 and root 3, and this one 2. And then you see how I'll just kind of copy this photo and show you. So if you just think about these triangles, sorry, it's 1 and 1 for 45. So when it's 45 degrees, you can call this 1 and 1. Of course, we can't call it 1 and 1 because it wasn't isosceles. So you call this 1 and 1, and then by Pythagoras, this is root 2. And then we can see here that tan of 45 is 1 over 1. So tan of 45 is 1. Sine of 45 is opposite over hypotenuse, so it's 1 over root 2. And cos of 45 is adjacent over hypotenuse, so it's also 1 over root 2. These are just, someone said, aren't you supposed to be a maths wizard? Yes, I'm sorry, I forgot a triangle. Gosh, I'm a fraud. But these are the triangles that you draw to remember 45s, 30s, and 60s. Okay, so hopefully that all makes sense. I still think that the easiest way to do it and how I did it was to remember it in this way with the root 0 up to root 4 for each of them. And the more you practice it and use it, the more you get used to it. So let's have another go at this again, shall we? So, and this time I will go through and tell you why the answers are what they are. So, okay, so 386, 865, I'll pop it in again in case people chat. There you go. Rosa Diaz, yes. Loving the Brooklyn Nine-Nine references. 10 PRs to bag, a classic. Oh, Logan Paul for life. We don't like that one. No, no. Jollof rice. I'm liking some of these. These are good. Okay, so there are 38 of you here. So I'll see if get almost everybody in. Someone asked, just while people are joining, if it says state the reason for congruency, what do I need to write? You need to write either SAS, ASA, SSS, or RHS. Like if you just write those kind of combinations of 3 letters, the examiner / your teacher will know exactly what you mean. Okay, someone said that they're still joining. Sway. Okay, I think I'm going to start now just so that we get it done by the end of the session. Okay, cool. You can join, I'm pretty sure, as I said, whilst it's in progress. I just don't want to run over into your lunch times. So let's get started. Okay, so same questions as earlier. Hopefully we get more than 40%. So start off with congruency, which were the lowest answered ones before. So which two of these triangles are congruent? Maybe you remember the answers from before, but remember to think about it. We either want SAS, so side angle side, ASA, so that's an angle, two angles in the side in between them, or SSS, so all three sides, or RHS, so for right angle triangles. So see as well, if you've already done it, pop in the chat, which rule was it? Yes, brilliant. Loads of people got that one. And people have said in the chat correctly as well. So Amelie said that it's ASA. So the reason that it is an A and C is because this 18 millimeters is not the same side. It's not the side in between the two angles. So it's got to be A and D because it's two angles and the side in between them. So yeah, really, really good job. Yeah, loads of people got that. Cool. So this time, which two of these triangles are congruent? Is this the one where I lied? Oh my God, it is. So it might not necessarily be two. It should just read which of these triangles are congruent. That is completely my fault. I'm very sorry. So again, if you get it, pop in the chat which one you think it is. Brilliant. Yeah, sorry about how the first time I got that one wrong. But yeah, so the reason that it is, so we work, because B's got the most information, we work from B. So B and C are congruent by SSS because we've got all of the sides exactly the same. And B and D are congruent by SAS. So we see we've got the 8 and the 5 and the included angle in the middle, the 60. And because B and D are congruent and B and C are congruent, that means that C and D are congruent, even though it's not kind of, yeah, by the same rules. So it's B, C, and D. So brilliant, well done. Okay, so on to similarity here, which you smashed the first time. Let's try to get 100% on this question. So remember, work out the scale factor and then think about what it will have to be. There. Oh, so close. Really, really good though. Really, really good. Yeah, so the reason is because the scale factor is 3. So when we multiply up the 3, we get to the 9. Brilliant. Well done. Okay, so now what's the length of DC? This is similar to one of the ones that we did. So remember to take into account this whole length here and work out the scale factor. And again, if you've done it, you think you've got the answer, pop on the chat what you think the scale factor is. Brilliant. Pathan's got it, Z's got it. Amelie's got it as well. Perfect. Loads and loads of you got that. So for those who didn't, the reason is because this is 8 and so AB is 8 and AC is 12. So that's a scale factor of 1.5. So we just times 5 by 1.5 and we get our 7.5. Cool. So we'll only run over by a tiny bit. 3 questions left. So Let's smash this 100%, super, super quick. Sine 30. That was loads of answers really, really quick. Well done. So if you get stuck, remember your 0, 30, 45, 60, 90. Think about what you get there. Yeah, well done to those of you who did. So, don't know why I clicked that. So sine 30 is 0.5. So that's our root 1 over 2. Is that what I meant? Yes, because that's just 1 over 2. Perfect. Scoreboard. Interesting. Okay. What's cos 30? So remember that this is our root 0 over 2, root 1 over 2, but backwards. So what's this going to be? Yes, excellent. Well done. So root 2 over 2, that's cos of 45. So if you put that one, that's where it was. And half is cos of 60. So if you got those. Okay, tan 45. You guys smashed this one before. So remember, this is one of the ones that you just have to know. So what do we think this one is? Yeah, look at these speedy answers. See, when I know they're speedy as well, I know that you're not, well, you possibly are using your calculators, but it's less likely. Because remember, these are non-calculator trig ratios here. Excellent, well done. So tan 45 is 1. Okay, let's see the podium for the final quiz. So yes, top 3 have got 7 out of 7. Oh, I cheated. Well done, well done. Emma came second, well done. You're consistently high, so that's really good. And in first place is the cool emoji. Love that. Nice name there. Okay, cool. So let's have a look at the report and see what the overall percentage was. 60%. Fantastic. That's gone up by so much. So we went from 40% at the beginning up to 60% getting everything right at the end. Fantastic. So that's really, really good. Very, very happy with that. Okay, yeah, I've got to finish on a maths joke. I have overran. Someone's just sent a maths joke. So it's not related, but we're going to go for it anyway. Why did the student get upset when his teacher called him average? Because it was a mean thing to say. Because, you know, the mean is the average. So thank you all very much for coming. Sorry I overran a little bit. Do check out the MyTutor, the online school ones. They've got timetables and stuff coming up. And also check out MyTutor's personalized one-on-one tutoring. Either contact them or they have a really good like search function for it on the website, which is really, really fab. So I will personally see you all again tomorrow, I think at 2 p.m. So have a fantastic week. Thank you for coming. Really good job today. And I will see you all tomorrow. Thank you guys. Bye.